Hello everyone. So in this video, we are going to talk about different types of methods which we can use to override the severity of any hierarchy or any class. So let's begin. So during our previous lectures, we did use some verbosity overrides method, as you can see it right here. And as you can remember, as the methods get more specific, they have higher priority over the not so specific one, which basically means if you write uh, both of them and both of them are targeting a certain level of hierarchy, the one which are more specific, like the ID verbosity and the severity ID verbosity ones, they will have more precedence than the less specific one, like the level ones. So in this video, we are going to talk about the similar methods for severity, and there are only two methods for severity. So let's begin. So the first method is just remember one thing. First, let me write this. Just remember one thing that for the override methods of the severity, you should also add override at the end. And there are no hierarchy variants of this. For example, in verbosity, you could have written hierarchy. So it will take into effect for the current class and all the class which are down to this hierarchy. But we don't have any alternatives, uh, the hierarchy alternatives for severity override. So there are two methods. This is the first one, and for this one, there are two arguments. The first argument is the targeted severity. Let's say we want to target UVM info, and the second method is the desired severity. So second argument, sorry. So with the second argument, the first argument will be replaced. So let's say I want to replace UVM info with UVM warning. So to make this work, we need to refer to certain hierarchy, the targeted one, because as you know that there are no hierarchy variants for this. So let's say we want to target uh, let's target the usual driver class, and here you can see that we have UVM info, and since our sequence is going to repeat 10 transactions, so we will have 10 UVM info from driver. Now what are we doing? So we are just changing the severity of this UVM info to UVM warning, and let's see whether it gets printed or not, whether it will print or not. And just remember one thing, we are changing the severity still. It is UVM info macro. So the verbosity threshold set for this macro is UVM high. So for this example, I will set it to UVM medium. so that it could print. And let's get back to our test class. And here we are targeting the UVM infos or the UVM info macro. And by default, of course, the UVM info macro will have UVM info severity, as I have discussed in my previous lectures. So let's target it. We are in the test class, and in test we have an instantiation of environment class, and inside environment we will have agent, and the instantiation is A, and inside agent we will have driver, and the instance is D, or the handle is D. So let's save the code and let us see. So as per our simulation run, we should receive 10 warnings from the driver object, I mean component. So I've saved the code, and I want to make sure that I've saved the code here. Yep. Let's compile the top. Let's run the simulation. Okay. Okay, for some reason I did not delete underscore hierarchy, as you can see, and this just proves that the severity override methods does not have the hierarchy counterpart which was available for the verbosity override. So I will go back to my test class, and here I will delete this. I will compile it again. Now this time it should run just fine. All right, so I get it. So these are some of the modifications from our last lecture. I did not touch the code, but I should. Let us see. Is it from the driver? How about it inside the start of simulation phase? Like we did for the verbosity override. And yeah, one more stupid mistake. I don't know why I passed the severity as string. So now this should work just fine. You should never pass your severity as string. I don't know why I did that. Still, let's get back to our simulation. We need to compile the code for one more time. Okay, let's see what we have here. So you can see that we have 10 UVM warnings and 24 UVM infos. And all of those 10 UVM warnings are from which class? You can guess it. It is from driver. Let me prove that. So we did get UVM errors because we did modification in our scoreboard. So yeah, you can see it right here that this is used to be the UVM info because there is no UVM warning macro inside the driver class. So that severity override just replaced the severity of the UVM info present in the driver class with UVM warning. And you can see it with other transactions also. It is UVM warning. And as I have already discussed that since we have 10 sequences, we will have 10 UVM warning. So that's how severity override method works. So before that, I will just make some corrections. So here we intentionally implemented a bug which will fail all the sequences so that we can check the max error quit count, which I did in our last video. So other than this, the other method is the more specific one, and the second method, the severity ID override. So this basically means it is more specific because it overrides on the basis of ID. So let's find out. So this time, uh, first let's write the method. So unlike the above one, this will have three arguments. The first argument will be the targeted severity. The second argument will be in the ID as a string, and the third argument will be the desired severity. So let us target the monitor class. So here inside our monitor, we have UVM info right here inside the run phase. And if we want, uh, what if we want to replace the UVM info right here with UVM error? Let's find out. And this time it should target the monitor class. So inside our environment we have agent, and inside our agent we have the handle for the monitor, and it's M. So let us comment this and let's see whether this works or not. First, let me check what is the verbosity threshold of the monitor class. It's UVM high. Okay. I will change it to UVM medium, and let's check this again. Alright, we are set. Let's see whether we have any compilation errors. We don't. Let's see if we have any runtime error. Okay, as you can see it right here that we have 10 UVM errors, and all of those errors are from the monitor class. You could see all the UVM info macros are replaced with UVM error because of our severity override. So other than this, we do have alternatives uh, in the form of command line argument. So instead of doing this modification in the code, we could just pass an argument during the simulation time. And that is very similar to what we did in verbosity override. So right now, let us just comment this and compile this code. So what if we want, let's target the scoreboard. So what if we want the UVM info present inside the scoreboard to, or let's say, let's implement the bug. So since we have implemented the bug in the checker, so there will be 10 iterations, and in each 10 iterations, this UVM error macro will trigger. So what if we want to change this UVM error to UVM info? Can we do that? Let's find out. So first, since I made this modification, I will compile the code for one more time. So it should be UVM set severity. Now, what are the arguments? There will be 10 arguments in total. The very first argument will be the hierarchy, and I will start from UVM test top, which is our test object, I mean component, and then I will write the uh, just a second. I need to write the entire hierarchy. So inside the top we have scoreboard, and we are targeting the scoreboard. Or we could just simply write star, so it will target any hierarchy down the UVM desktop, since we are already filtering it using the ID. So the ID of the scoreboard is scoreboard because we used the get type name method. And the third argument is going to be the targeted severity, and we are targeting UVM error. And the last argument Oh shit. Okay, I will do it again. So the first argument will be the hierarchy, and I will just write. Second argument is going to be ID, so I will write scoreboard. The third argument is the targeted severity, and it is UVM error. And the final argument is the desired severity, and it is UVM info. Or let let us instead use UVM warning, because there is already a UVM info inside the right method, I think, or inside. I mean, there are two UVM infos inside the scoreboard. So I will just replace the UVM error with UVM warning. So these four are the arguments, and let us check whether this will work or not. So just to recall again that I intentionally implemented this bug in the checker, and it should trigger UVM error every time. And in our command line, we are replacing this UVM error with UVM warning. Let's run our simulation engine. Let us see what we have here. So just by looking and taking a first glance, you can see that in the summary, we do have 10 warnings, and all of those warnings are from the scoreboard. And we successfully replaced the UVM error of the checker with UVM warning. And this is the string. Just to confirm, we have the same string right here. So yeah, since there are 10 total sequences, the transaction items, so there are going to be 10 warnings. So using the command line argument, we just replaced the UVM severity of the scoreboard. So the final topic of this class is going to be the priority. So which particular method has higher priority when compared to other? So let's check this out. So let's go back to our test class. And here first we will compare all the severity override methods which are present inside our class. We will force them to target the same class. So let's say we are targeting monitor in both the cases. So remember, the second argument is more specific when compared to the first one. Second method, I mean, because it has an additional argument, the ID. So let's find out which one replaces which. So just to ensure it that we are being fair, I will just move it right underneath it, and I will comment this one out. Now it is coming right after it. So usually it should replace the upper one, but this one is more specific. It also has ID as an argument. So if this one wins, the UVM info macro the inside the monitor will trigger UVM errors, and there are going to be 10 errors in total. And if this wins, then there are going to be 10 UVM warnings. So let's find out what happens. And also, I will just correct my scoreboard checker logic just in case we don't have any confusion. All right, so let's compile the code. Let's run the simulation. Okay, let's see what we have here. As you can see that we are having 10 UVM errors, and as I can recall, this particular override method was replacing the UVM info with UVM error, and we don't have any UVM warnings. Yeah, so let's check our transaction for monitor, and you can see it right here that it is being changed to UVM error. Here in our other transaction, it is the same. So the priority is still the same. The ones which are more specific will take precedence over the other. So let us just comment this out and let us compare this with the one we have in the command line. So what I will do, I will keep that as it is, and it should target the monitor, and it should change the severity of the UVM info macro present inside the monitor to UVM warning. And in the same time, simultaneously, I will change the command line and I will do the same replacement. The replacement is that all the UVM info will replaced with UVM error. So let's find out which will take precedence over the other. I have to compile the code again since I made a modification. So let's run this time using the argument UVM underscore set underscore severity, and our very first argument will be the hierarchy. So let's target the monitor. So UVM desktop, and inside UVM desktop we have, just keep it as it is because it is going to target all the hierarchy down to it anyways. So let us keep this, and inside this the very first argument will be the ID, and the ID of the monitor is monitor in our environment. And the second argument is the targeted severity, which is UVM info. And the last argument is the desired severity. Since we are already replacing this severity with UVM warning in our code, so we will replace here with UVM error. So let's check everything. All right, let us run the code. So if we receive 10 UVM errors, the command line argument wins. And if we receive 10 warnings, the one which is written in the code wins. Okay, you can see it right here that we are getting 10 errors, even though the replacement is made inside the code. So it does not matter that whether it is written inside the code or inside the command line. The level of specificness matter because this one was more specific, the one which we wrote in the command line. Because here we are also writing the driver, the ID, monitor ID. So let's take it to the next level. Let's say that, let us comment this, and this time we will find out that both of them have the same level of specificness. So which one wins? Let's find out. So here I will change it because it is also replacing the UVM info with UVM error. So this should replace it with the warning. So let's see which one wins. First I will compile the code. Then I will run using the same command line argument. So if we receive 10 errors, the command line argument wins. Or if we receive 10 warnings, the one which is written inside the code wins. Okay, what do we have right here? So we have 10 warnings. So if you have the same level of specificness, the one which is written inside the code will take more precedence, will have more priority over the one which you wrote in the command line argument. So this is all about severity override methods. We only have two methods which I just showed, and it does not have the hierarchical counterparts like we had back in verbosity. And we also have another means of doing the same during the runtime, and that is using the command line argument and passing that. And still, the level of precedence is same. The one which is more specific will take precedence over the other. So I hope you find this video useful, and thank you so much. And stay tuned for more. Thank you.